Hello everybody and welcome to part 8 of my FTC programming tutorial videos. Now in this video we're going to cover something very basic. I'm just going to call it drive power scaling, and all that means is that we're going to kind of control the maximum power of our drive motors at any given moment. Now if you've tried any of this code up until this point, you might have noticed that it's actually very difficult to drive the robot in this way, and that's because all of the drive motors are basically running at 100% of their maximum capacity at all times, and that's probably causing problems like slipping, and you're not able to control the robot the way you want to. So in this video we're going to cover one of two ways that I like to kind of control the drive powers of the motors. So let's get into it. So what I'm going to show in this video is how you can use one of the triggers on the drive controller in order to kind of slide or scale the power. So in this particular example, let's just call this variable power, and we're going to calculate this variable using a few different things. So first we want to determine what the maximum drive speed that we want our motors to run at. I always choose 0.8 for this. You might want to play around with it. Maybe you want 100%, in which case this number would be 1. Maybe you want 70, 75. This is something you can kind of play around with and figure out. Now we want to subtract this number from an additional number. Now this number is going to determine what your minimum drive power is. So the difference between this number and this number is what's going to determine what the minimum drive power is. I think the minimum drive power should be no less than 0.2. You can make it less if you want, but at that point you're starting to get into territory of your motors might not be able to move your motor at all. They just need more voltage in order to start moving in the first place. And we're going to multiply this value by gamepad 1 dot right trigger. Now you can obviously also use the left trigger if you want, and this value, much like the left and right sticks, is going to give you a floating point number from 0 to 1. So if you can imagine, if we're not pulling in this value, if we're not pulling in this trigger at all, this parentheses, this quantity, is going to be evaluated to 0, which means our drive power is going to be 0.8. And what we can do with that is we can wrap all of this in one additional set of parentheses, and we can multiply it by the power. Now, all of these drive motors, whatever the final calculated value is for each one, is going to be multiplied by power. And since power is going to be anywhere from 0.2 to 0.8, it's going to decrease the values, so we don't need to worry about our motors giving maximum drive power when we don't need it. Another thing you can do with this setup is, instead of having it so that when you don't pull in the trigger you're running at your maximum power, if you want to set it up so that when you pull the trigger in then you're speeding up, you can do this by setting this first variable to whatever your minimum power is going to be. So in this case, I'm going to set that to 0.2. And then you can, instead of subtracting this value, you can add it. So now the maximum power is going to be the sum of this first number and this second number. So in this case, it's still going to be 0.8. Now, as you pull in your trigger on your drive controller, you're going to be increasing the power of the motors on a sliding scale. Okay, I hope that was helpful for you in order to kind of control your robot better. There is one additional way that I like to control the power of the drive motors, which you might find more helpful. It's using a toggle button to toggle between two different speeds. I'll cover that in a future video as we need to discuss one additional topic in order to cover that. So I hope this was helpful. Let me know if you have any questions.